Okay, cosecant theta equals -2. So we're going to solve this using the unit circle, but first thing we always need to do is change everything to sine, cos, or tan. So the trick on this one is just knowing where you flip. When you're finding the cosecant of pi over 6, you find your ratio and then you flip it. It's kind of different when you're solving. So that's what our trick is. So on this first one, we're going to take it a little bit slow and show you how it works, but then from then on, we'll go quickly on the other examples once you know what it is that actually flips. So on this one, what I'm going to do is cosecant theta equals 1 over sine theta. So I'm just going to substitute that in, and then I'm going to multiply both sides by sine theta to get it out of the denominator. So I end up with 1 equals -2 sine theta, divide both sides by -2, and I get sine theta equals -1/2. So this is the pattern. When you're solving, it's always the reciprocal of the ratio. So if it's cosecant theta equals -2, then I know sine theta is -1/2. So that's the pattern we're looking for. Now we're just using the unit circle to solve this. Sine theta is -1/2. I'm looking for y values of -1/2, and I should find those at 7 pi over 6 and 11 pi over 6. B, cotangent theta equals -√3, so then that means tan theta equals -1 over √3. Now, I always with tan, I kind of split things up, so I know that the numerator is 1/2 and the denominator is √3 over 2. I know that the numerator as well, the top, is my y value. So I got y values of 1/2, and the denominator is the x value. So I know the x values are √3 over 2. The negative comes from that one of them's negative, one of them's positive. So it gives me two different possible coordinates for points. So one of them can have an x value of -√3 over 2, comma, y value of 1/2. So one's negative, one's positive. Or the other possible point is that it's √3 over 2, comma, -1/2. So if I go 1/2 divided by √3 over 2, I get the 1 over √3. Positive divided by a negative, I get a negative. Okay, so either of those 2 points is possible. So all you need to do now is get out your unit circle and find those 2 points. So -√3 over 2, comma 1/2 is the point on the circumference of the circle at 5 pi over 6. And √3 over 2, comma -1/2 is the point on the circumference of the circle at 11 pi over 6. So those are our two solutions. Theta equals 5 pi over 6 and 11 pi over 6. And on to C. Secant squared theta equals 2. So I'm going to change this to cos squared right away by, again, it's the reciprocal of the ratio. So cos squared theta equals 1/2. Then I'm going to take the square root of both sides. Make sure whenever you take a square root, it's always plus or minus. So I'm going to get cos theta is plus or minus the square root of 1 over 2, but I know the square root of 1 is 1. So this is the same as plus or minus 1 over √2. Which is the same as plus or minus √2 over 2. Now get out your unit circle and figure out where are the x values. Positive √2 over 2, and there you'll find it's at pi over 4 and at 7 pi over 4. And then where is it negative √2 over 2? And that's at 3 pi over 4 and 5 pi over 4. So it's positive √2 over 2 at pi over 4 and 7 pi over 4, negative √2 over 2 at 3 pi over 4 and 5 pi over 4.